I really have to pee. Hello everyone, it's January 16th. Alright, I just watched the interview of Learner Tian after he beat Daniel Medvedev. And it was a 5 set thriller. But the fourth set went very fast. I think, if I'm not mistaken, most of the sets lasted like 40 to 50 minutes because the whole match is 4.5 hours. But the third set, I think, is less than 30 minutes. So in the interview, the interviewer was asking, like, what happened on the fourth set? Did you just drop your concentration, you drop your form or whatever? And then learner just said, you know what? I just really had to pee. It's like the most honest answer I've ever heard. Yeah, you're in a match, fourth set, you want to pee and you feel like I cannot concentrate. So let's just finish this one as fast as we can, and then we go back to do the fifth set. The audacity to do this against Medvedev. I don't know how he's ranking right now. I guess top 5 at the moment. You know what? Let's check. I'm not sure where he's ranking. Probably spelled his name wrong. Yeah. He's currently ranked. He's only 28. Damn. But Learner is only 19, so that's that. What's his current ranking? Wait, where's the ranking? Singles. Current number 5. Right? So he's number 5. And to face a rank 5 player, and you're like, I'm gonna let the fourth set go because I really had to pee. That's another level. Oh yeah, look at the fourth set, right? He just definitely just let it go. He didn't really didn't really even try, right? But when he did try, and he said it was a shame that he couldn't get the third set. So the fourth set he had to pee, so he just let it go, and the fifth set he got back. Yeah, it was amazing, right, for a 19-year-old to do something like this. All right, what is going to be even more amazing is I'm gonna do today's challenge. Oh, 70% passing rate. We're gonna handle this really fast. All right, neighboring bitwise exclusive OR. So we have a zero indexed array derived with length n. Oh, I just farted. It smelled terrible. Jeez, man. Holy crap. Oh, I gotta take a minute. Oh, boy. All right, with length n is derived from computing the bitwise exclusive OR of adjacent values in a binary array of length n. Huh. How'd you get length n from n? Shouldn't it be n minus 1? For each index I in a range, if I is equal to, oh, I see, you do a wraparound. Otherwise, you do your current and the next. Okay. Given array derived, your task is to determine whether there exists a valid binary array original that could have formed derived. Return true if it exists, false otherwise. Okay, so if I'm giving 1, 1, 0, that means we have, it's called x0, x1, x2. So we have x0 exclusive of x1 equal to 1, x1 exclusive of x2 equal to 1, and x2 exclusive of x0 equal to 0. Now, this means x2 must equal to x0, right? These two must equal. And yeah, this is true because these equal, you can do this. So we need to identify these type of, need to identify if it's possible or not. You know what? I think it's very simple, right? We just start with, because at a position, it's either 1 or 0. So we start with 1, okay? And then I think derived 0 is, yeah, so Basically, we do this exclusive of this, we get this. This exclusive of this, get to this, and then this exclusive of this, we get this. If it's good, then good. If it's bad, we swap to 0 and then do it again. If you go 2 times, you couldn't, then that's just not possible. Yep. That is why it has such a high passing rate. It's a simple problem, right? That's not hard at all. What is hard is yesterday's problem, that tough one. I kind of said I'm gonna think about it, but I don't think I did. I went to bed, I read before I fall asleep, and then I didn't really think about it again. Shame. All right, so we're gonna say trial 1, right? Trial 1. Start from 1. So we can go, yeah, so just int start is equal to 1, and we need int current, right? We'll have a start, we'll have a current, both is 1, and then we say for int I, 0i smaller than derived dot size I plus plus. So basically what we're trying to do is to compute the next one. So we say current shall equal to current exclusive or derived I, right? So this one, oh, I can actually simplify it to this, right? So we do this, we get the next one, we get the next one until I is equal to n minus 1, right? So I is equal to n minus 1. So here we compute, we get this, and then we exclusive all, we get the next one, and then we exclusive all, get the next one. So actually we get back, right? We get back to the start. So all we need to do at this point, we should say if current is equal to start, now we just return true. Otherwise, trial 2, start from 0. I wonder if we even need to do this. St equal to 1, no, st equal to 0, and current equal to 0, right? Say for int I 0, I smaller than derived dot size plus plus. Oh. And say current exclusive for equal to derived I, and then if current equal to st, return true, otherwise return false. I am not sure if we need to go through this, because to me one of them should be enough, because it doesn't really matter, right? It doesn't really matter. You know what, let's be bold. I think this is enough. I think this is enough, because when you swap it, it's just exactly the same. 2683. You know what? Even better, I start with 0. I can start with 0, and then this one become 1, this one becomes 0. Why you start from this? It's the same thing. Just try it. Just set a starting value and go through derived, right? Derived to produce what the original should be, right? And then compare the computed first starting value with the actual starting value. If the two are the same, it is possible. Otherwise, it is not. It does not matter what value we start. It can be 0 or 1. So we run it, make sure everything work as expected, then we submit it, and we'll score 0 millisecond. I have absolutely no idea why it costs 11 milliseconds. Like, what the hell? I just went through this thing. Why it cost that long? Alright, technically I don't need to use I can just, are you kidding me? So you're telling me that this will actually be faster. I refuse to believe it, but I'll try it. It is slightly faster. Alright, we'll record this. 7, 29.44%. Still weird that it's all, like, is there a better way? Some better way I do not know. What was my submission before last time? Why do you reverse it? Oh, I realized something. Maybe you can just exclusive all everything and see if it's equal to 0. Yes, that probably is. So what you're saying is just exclusive all everything. Just exclusive of everything and derived. It should, if it is valid, if it is possible, right, to find a original, the total exclusive of should be 0. Is this the holy grail? Wait, what? Probably cannot use exclusive or. Yeah, I don't think I can use exclusive or. Okay, it's pretty wild. Okay, it's pretty wild jumping back and forth. It's 8 milliseconds. Nah, that's alright. We know what this is. Oh. Cumulative. Yeah. Some parity. Oh, okay, this. Some parity. Ah, yes, it has to be the even count, right? Some of it must be even, yep. Some parity. Ooh. Accumulate. That is interesting. Okay, let's just see if this is the actual. We can. This is from. This is from the official solution. We can also check the parity, right? Parity of the number of ones. It has to be even. So I can turn this into a one-liner. That's the thing, right? We can return accumulate. I'm pretty sure you'll have stds attached to it. Mod 2 equal to 0. Is this the Holy Grail? Almost. This is almost the Holy Grail. 3 milliseconds. Alright, I actually want to record this. This one's pretty good. This one's pretty gnarly. I'm just going to change this. Ooh-wee! Something needs to be included in order to use. Numeric. That's the one. I have to include a numeric. Alright. We upvoted. This one's good. Okay, we got stuck on this one yesterday. I think it's pretty hard. Okay. So it says max summary sum after removing something. So what we're thinking is we will group all the positive together. Because if it's all positive, then we just add them together. If it's all negative, we just choose the largest negative. Well, the smallest negative, right? And if they're a mixture, then we definitely need to remove some negative. And the positive need to stick together. So I say for all the islands of positive, we put them together. Well, technically we can for all the islands of negative, we put them together as well, right? And we can shrink the number, so we get a new one. But we cannot do it like that because then we don't know which negative to do. So we have all the negatives spread out like this. We don't know how many negatives there will be, so there will be a bunch of negatives. And when you remove one, right? I mean, you can try to see what. Okay. Because we're dealing with maximum subarray sum. And we have these positive islands, right? Then the positive islands can stay by themselves. So the biggest of them has the potential. And then we can see whether we can join them, right? And it has to be that the join, when you join the two, it must. So yeah, we have like a positive here, then we have a positive here, we have a bunch of positives, and we have some negatives, right? So basically, if I join the two, it will create more value, which means this one, this positive, must be bigger. Or when this adding this, like these has to be larger than 0. Like if they're not larger than 0, why do you join them? Right? You could just because you want to make it bigger than this one, and you also want to make it bigger than this one, right? So it has to be beneficial for the two to join, which means actually not just this, you can also say this adding this need to be positive, right? Otherwise there's just no point to join them. And you can do this one as well, these two as well. And what I'm thinking is you basically, so yeah, so like if I'm looking from the perspective of this, right, this one, and my goal is to say, should I join the next big positive? And to join the next big positive, I need to, actually, I think it has to go both ways, right? It has to go both ways. Because if this plus this is a positive value, then it's bigger than this. I mean, essentially, let me think again. Because the goal is we need to remove something, right? So the negative to this side, the negative to the other side, we don't really consider, right? It doesn't really matter. It doesn't really matter to us. What matters to us is we want to join all the positive together, or as much as we can, right? And we want to see if we remove some negatives, it can make it simpler. No clue. DP and segment tree. Oh, please don't. Ugh. Jesus. Each node of the segment tree should store the subarray sum. The maximum subarray sum. The maximum prefix the max prefix sum. What? And the max suffix sum within the subarray defined by that node. Holy guacamole. All right, now we have some pointer to think about. Let's think about it. I'll see you guys tomorrow. Adios.